to meet everyone on the call today. So a little bit about myself. So I currently lead our go-to-market strategy for analytics at AWS. I've been at AWS about 7.5 years, which is, I guess, kind of from the beginnings of cloud adoption to where we see it today. And I thought a fun fact to share. So I currently live in Arizona. If you've ever been to Arizona, we're known for sun, golf, and our saguaro cactuses. Oftentimes, these are the iconic views of the desert southwest of the United States. Interesting fact, they can grow up to 12 meters in height, and they can live to 200 years old. So if you ever see any of the saguaros that have the iconic waving hello arms, a saguaro will only grow its first arm after 100 years. So they live a long time. And besides living in the desert here, I really enjoying the outdoors and mountain biking with my daughter on our endless mountain trails. So if you ever get the chance to come to the Southwest, I'd love to welcome everyone to our beautiful sunny environment here. So today's topic, we wanted to talk about real world evidence in life sciences. And I think particularly today, given the environment with COVID and this, focus on discovery and collaboration in pharmaceuticals industry to make our lives better. This idea of combining multiple data sources with SnapLogic and AWS to effectively communicate drug discoveries better to researchers and scientists and to regulators. And so we think about some of the design criteria for real world evidence includes being able to ingest data at scale, thinking about a single source of truth from different trial participants, researchers, collaborations, regulators, but then also, thinking about doing this globally, right? Obviously, there's different regulations in each geographic area we might operate in, but more and more, empowering the researcher, the data scientist, the analyst, right, with the right information, and doing so in a cost-effective and secure manner are all sort of basic requirements when we think about real-world evidence in life sciences. Now, besides just these requirements, I think it's important, particularly in today, to really focus on agility. And here's two quick examples from customers that use AWS. Bayer, who is one of the largest manufacturers of ventilators, who, as you can imagine, faced unprecedented demand both for sales and marketing, but also their supply chain to deliver ventilators across the world, as well as Moderna, who obviously has developed one of the current COVID-19 vaccines. And what they had in common was really unprecedented demand and unprecedented pressure to deliver. And both of these customers relied on AWS, and we partnered closely with them to meet the scale and hopefully deliver better outcomes for the world as well. But thinking about agility, we think like, what are some barriers to agility, right? And this will kind of lead into my subsequent conversation around the Lakehouse architecture. But what we've seen from customers, whether they're on-premise or the cloud, or they're looking at data integration challenges, oftentimes, we end up building data silos, which obviously present barriers to adoption and lacking the insight across all the data. And so things like, design patterns like separating compute and storage, thinking about, if I have data in proprietary formats that are only accessible to one system, but then also, how do I actually get my consumers of the data access to the right information? And if data is in different silos, if it's in proprietary data formats only accessible to one particular system, becomes a real blocker, right? But then once I combine the data and I go through my data transformation process into a data warehouse like Amazon Redshift, I want to make sure I have the full richness of analytics, including machine learning, without having to export or move data around, right? And then also, thinking about cost, right, and performance, which become really critical to being able to deploy this at scale, are all sort of things we hear from customers around blockers to this agility. that the promise of AWS in the cloud, along with SnapLogic, can deliver. So think about, one way that we see customers overcome this is looking at a cloud data warehouse like Amazon Redshift to be the center of their real-world evidence applications. AWS and SnapLogic, we have hundreds of joint customers that work together on a daily basis to deliver this performance. And it's really predicated on, analyzing all of your data, whether it's structured, unstructured, whether it sits in a data warehouse or a data lake, right? And being able to assess that data regardless of its location, but then have a high performant way to transform and load it as well. But then also being able to think about performance at any scale, right? Whether I start off with gigabytes of data, terabytes, hundreds of terabytes, all the way up to petabyte scale data, being able to get the right performance and the right insights. And of course, paying for what you use, not having to prepay for capacity, being able to pause and resume when needed, and then having that predictable cost as well, right? So that are all sort of key in terms of getting the right access to data. Now, thinking about this idea of a Lakehouse approach, and what does this really mean? Well, in the barriers to adoption, I covered a little bit this concept of having different silos of data. And so fundamental to the Lakehouse approach is to break down the barrier between a data warehouse and a data lake, to give access to business analysts or researchers through SQL, through a single endpoint, but then combining the structured, unstructured data, combining real-time data that could land as a stream of data into Amazon S3, for instance. But then where needed, knowing that there are other data sources available, and if I need that real-time view, I can use things like federated query or materialized views, as well as leveraging the power of machine learning to get better insights to data. And this concept of, it's not necessarily a product, thinking about a lakehouse, but it's really this approach that's predicated on breaking down data silos and really delivering insights across all of my data. And so a couple of things I just wanted to deep dive on that I think are important, particularly in the context of real world evidence, and really some reasons why customers look to Amazon Redshift to be at the core of their Lakehouse architecture. The first is in-database machine learning. So the concept of in-database machine learning, I think, has been around for a number of years, but one of the trends we've seen over the past 3 to 5 years is more and more customers adopt Amazon SageMaker as really that data scientist workbench to be able to get access to all their data. And these typically are more technical users that are using things like a Jupyter notebook to access data, but then want to be able to expose that to a wider set of analysts. And so in preview today, we have a feature called Redshift Machine Learning that allows the non-data scientist, I sometimes refer to as the citizen data scientist, or someone who understands SQL, to not have to worry about Python or Scala or the languages of machine learning, but simply create models directly through SQL syntax and then deploy and run those predictions without having to export data. And this has been really powerful for our life sciences and a broader set of customers to be able to expose the power of machine learning, but then combining that with the database of Amazon Redshift. And even though behind the scenes we invoke things like Amazon SageMaker, that's really abstracted from the end user. They simply can access that data in Redshift, build their models, and then importantly, run those predictions against those data sets as needed. Another really great enabler for collaboration in real world evidence becomes a new feature which just went generally available in the last few weeks for Amazon Redshift, which is data sharing. And so the idea of data sharing is, imagine I have my data transformation workload set up. So I have my transforms in SnapLogic, and then I have a compute cluster, right, or a set of compute we call the endpoint, or sometimes the producer. This is really where my data is ingested into Redshift. I'm doing my data transformations through SQL if needed. And this integration point, obviously, if I'm running, particularly during peak times of data loads from SnapLogic, I want to make sure I right size and look at cost as a key component of that producer cluster. But then as data is loaded into Redshift, I can now have a separate set of compute environments with potentially their own or similar endpoints. So a researcher using a business intelligence tool or simply writing SQL can have a dedicated set of compute that is right-sized for their environment, right? That can be and span potentially different geographic locations as well. So if I'm a researcher, if I'm a marketer, if I'm in sales, I can now not be reliant upon the compute on one cluster, and really kind of open up the type of analysis that's available. And so this data sharing, has been really popular in the last few weeks as we went to GA, and really helps enable this discovery and not having to think about or overthink how I can combine this data transformation as well as analysis by giving these segregated compute environments becomes really key. Another piece I'll go quickly through is a new data type in Redshift that we call super. And so particularly in real world evidence, where I'm in particularly around manufacturing, if I have data that is more in terms of the unstructured nature, or could be nested data. And so now in Redshift, we have a new data type called super that allows you to natively load these nested data structures, but then query them through the dot notation of SQL as well, and get full access to that nested data directly from Redshift as well. And of course, performance becomes a key consideration, and how I'm able to get the best performance and best cost. This is something that AWS and Amazon Redshift have heavily invested in to be able to provide automation. And so our basic mental model today is to load data into Redshift, start querying it, and add users, right? And so with the automation in Redshift today, some of the performance tuning in the past that might have been required by database administrators is all handled through automation and machine learning to be able to give not only the best price performance, but the overall best performance as well. And of course, particularly in life sciences, but in many different regulated industries, the idea of access and auditing and encryption and third-party certifications become really key. And so with a flexible set of audit access controls and encryption, Amazon Redshift can be used to store your most critical customer data, and is leveraged across many different countries, industries around the world. And importantly, it comes at no extra cost. And so there's no special version of Redshift that has these encryption features, but can be leveraged natively as part of Redshift itself. So I know I went kind of quickly, but there's a few steps if you're using Redshift, if you're getting started. I always love to reach out and talk to customers myself. There's ways to get demonstrations. We have a great marketplace listing with SnapLogic where you can get more information. But having said that, I just wanted to thank everyone for the quick overview of how AWS, SnapLogic, and particularly SnapLogic with Amazon Redshift can be the foundation of your real world evidence in life sciences.